So we're going to do some reviewing here. This will be not over the whole chapter, but just on lessons 4.5 through 4.8. If we look at our vocabulary a little bit here to start out with, a term that contains only a number is called a constant. Good. So some examples of constants, we've got 5 and -2 would be examples of constants. And then number 2, the number part of a term that contains a variable is coefficient. Good. So coefficient, for example, if we have 4x, just to be clear, if we have 4x, the 4 would be our coefficient there. And then, variable is a letter that represents an unknown value. So examples of variables x and y are two common ones. So on page 245, lesson 5, we talked about factoring expressions. Factoring expressions is basically the opposite of distributing. It's kind of a working backwards process. Think about what did we have first that when we distributed gave us this answer. In other words, looking at these terms here, what do they have in common? Now, like we've done, if you guys want to right off the bat when they're subtracting, if you want to add the opposite there, you can. If that helps you out, you don't have to do it that way. We'll talk about more in a minute. We're going to look at these numbers first of all, 63 and 42. 63 and 42, we might have a little difficulty just looking at that and telling what they have in common. What we can do is a factor tree, we can break these numbers down. So what numbers could we multiply together to get 63? 9 and 7. Good. So 9 times 7. If we want to, we can further break this down into prime factors. So 9 we could break down 3 times 3. Good. Okay. And those are all prime then at that point. 42 we could also break down. 42 is what? 6 times 7. Okay. And then 6 is? Okay. So that's doing the prime factorization or doing factor trees. Then what we can do is look for what they have in common. Look for what they both have. So one factor they both have is a 3. Good. They both have a 3. So that means I'm thinking about 3 is going to be involved with this somehow. Is there another factor that they have in common? 7. Good. So they've got a 3 in common, they've got a 7 in common. If there's more than one factor in common, we can multiply those together. So 3 times 7 would be 21. What that means is I can factor a 21 out of this. We can factor 21 out. We'll double check with our variables. Variables are different, so we can't do anything there. So if we factor a 21 out, think about what we would have left. Well, actually a nice way of doing this, since we did our factor trees, we can look for literally what was left that we didn't use as factors to get 21. So the only thing left over for the 63 is we've got a 3 here. Okay? So 21 times 3 must be 63. Does that make sense? Okay, and then besides the 3 we also need an A. So 21 times 3A, if we would distribute that, that would give us the 63A. And then if you want to, you could say plus a negative, and then same thing. Look for what's left over here. With the 42, what's left over is 2. So that'd be plus negative 2B. If you wanted to, you don't have to add the opposite here. You could do 21 times the quantity 3A minus 2B would be fine also. Either way that you write that would be fine. So we look at number 2. Similar idea here. We're trying to factor this, so we're going to look what these have in common. Again, with the 81 and 54, we might not be able to just look at it and tell. what's in common, so we can do factor trees again. 81 we might see as 9 times 9. 9 is 3 times 3. 9 is 3 times 3. Those are all prime. 54 we might see as 6 times 9. 6 is 2 times 3. 9 is 3 times 3. Again, once we've factored it down, now we're going to look to see what they have in common. So, seeing a lot of 3's here. We've got a 3 in common. We've got another 3 in common. And we've got another 3 in common. We look at our other ones. We've got a 3 here and a 2 here. Those don't match. So those are not in common. So if we look at this, 3 factors of 3, so we could do 3 times 3 times 3. So 3 times 3 is 9 times 3 is 27. Good. Okay, so 27 is going to be the number that we're going to be factoring out here. And we'll look and see what we have left. So 27 times what to get 81y? Look at our leftovers here again. With the 81 we have a 3 and we need a y also. Good. And with the 54 we've got 2. 27 times 2 is our only leftover there, would be 54. So this could be our answer for that. Now, one thing the book points out here, there's actually technically different other ways that we could work this one out as well. This is what I would consider the best answer to this problem. If you didn't factor out quite as much, let's say we only factored out a 3, that would be 3 times the quantity 27y plus 18. We could have factored out a 9, and then it would be 9 times the quantity 9y plus 6. So actually any of those 3 would work, but again, what we did, as you move along in math, I'm going to consider that the best option. Factoring out the biggest possible number will benefit you the most as you go along in math. So if we look at number 3, which show a way to factor the expression 32t minus 48, select all that apply. We could actually work this out, think about what we could do to factor. It might be just as easy for you guys, depending, to just distribute these and see what you get. If you wanted to, anytime they're subtracting here, if you want to add the opposite on those, you can. And then one way of doing this, like I said, is just distribute and see, do we get 32t minus 48 or 32t plus negative 48? So if we do this first one, we've got 2 times 16t, so 2 times 16 ends up being 32, so that would be 32t, and then 2 times 24 is 48. So this would be 32t plus negative 48, or 32t minus 48. So that one works. If we look at our second one, we distribute here. 4 times 12 is what? 48. So that'd be 48t. I don't really care what this other part is. It's not going to be 32t something. So that one doesn't work. The next one, 6 times 26, is that going to be 48? No, that would be quite a bit more than that, so that doesn't work. 8 times 4, okay, so that's 32t, and then 8 times 6, 48. So 32t plus negative 48, so that one works. And the last one, 16 times 2, oh, that looks backwards of our first one. That's 32t. And then 16 times 3 ends up being 48 also. So those would be your 3 choices. Again, you could try to go through and think about, which ways can I factor different numbers out, but actually just distributing and then seeing if they're equivalent to that might be the easiest way for you guys to get that one. Lesson 6 and 7, they combine to one here, is adding and subtracting expressions. So if we look at number 1, you can see on number 1 they're adding those together. Adding, anytime there's subtraction signs, if you want to add the opposites here, you can. And then we're just going to look for like terms. If it helps you to rearrange and get your like terms next to each other, you can do that. You don't necessarily have to. So in other words, if you wanted to get the C's next to each other here, and then get the constants next to each other and then work it out, you can. If you don't want to, if you just want to hunt to find those like terms and then combine them, that's fine also. So we look at this, we got two C terms we're going to be able to combine together here. And if we look at these, some of these are positive, some are negative, so these are fighting it out. And we have more that are positive. Since they're opposite signs, we are going to subtract. So 5 2/10 minus 3 9/10. We can borrow. Whoops. Is 1 3/10. We know we have more that are positive, so this would be 1 3/10 C. And then with our constants, we can combine these together, and these are same or different signs, so we're going to subtract, and we have more that are negative, so it's going to be negative. Good. Alright, so that's going to be a plus a negative 4 70/100ths, or if you just put 4 7/10ths, we don't really need that 0 on the end of that if we don't want. Another way you could write this would be to say 1 3/10 C minus 4 7/10ths, or minus 4 70/100ths. Either one of those would be fine. Number 2 is different than 1 because we're subtracting in between here. So we're subtracting. When we subtract and we have something in parentheses, what do? Add the opposites. Opposite, opposite, however many times we need to. Now that first expression, we had subtraction signs there. If you want to add the opposite on those as well, you can. And maybe let's back up for a minute here. I forgot about, in that second set of parentheses, we had some subtraction. So if you want to, you can actually start that second set of parentheses. You can add the opposite there if you want. The negative 5 at the beginning, it doesn't really have to be added the opposite, but if it makes you feel better, you can add the opposite there too. Okay? And then we can add the opposite, opposite, opposite on that part that's being subtracted. At that point, again, if it helps you, you can get your like terms together. Now it's going to be just like we did with addition. Quick. So combining like terms here, we've got two x terms, 6x and 8x combined together would be 14x. We've got a negative 2y and a negative 9y working together here to make a negative 11y. And then on our constants, we've got a negative 5 plus 5 is 0. If you want to put plus 0, you can. We don't really need to do that because adding 0 doesn't change anything. So this could be our final answer, or you could have had that as 14x minus 11y would be the same. We look at number 3. Last week, Jean ran 2 fewer than m miles. This week, she ran 5/10 of miles more than last week. write and simplify an expression for the total number of miles Gene ran in the 2 weeks. So last week, if we think about this, 2 fewer than 4m would actually be 4m minus 2. We start with 4m, we take 2 away from that. This week she ran 5/10 miles more than that. So we'd start with the 4m minus 2, but then we add 5/10 to that. So that would be our starting expression, and then we would just be simplifying. So simplifying here, we can add the opposite where they're subtracting. We can combine our m's together, so 4m plus 4m would be 8m. We've got a -2, a -2, and a 5/10. -2 plus -2 would be -4, and then -4 plus 5/10. Those are opposite signs, so they're fighting it out. We have more that are good. We have more negatives by 3.5. So 8m plus -3.5 would be an expression for the total miles Gene ran. Could also write this as 8m minus 3 5/10. Lesson 8, we're analyzing equivalent expressions. So if we look at number 1, Hal earns N dollars per hour. Next month he will receive a 2% raise in pay per hour. The expression N plus 200 N is one way to represent Hal's pay per hour after the raise. Write an equivalent simplified expression that will represent his pay per hour after the raise. So they were pretty specific here. Not only did they say a simplified, or rather an equivalent expression, they said an equivalent simplified expression. So that means any like terms that we have, we need to make sure we combine those together for our answer. This one, we've got the N plus 200 N. So the N, there's nothing in front of it, means we could put a 1 there. So we've got 1n plus 200 N. These are like terms, so we can combine these together. So the 1, the decimal point would be after the 1, so that'd be the same as 1 and 0/100 plus 200 would be 1 and 200. So that would give us 1 and 200 N would be an equivalent simplified expression. Another way of doing that we've talked about is we can look at our percents. If we're getting the full amount of what we had is 100%, and then 2% raise, so plus 2%, so 100% plus 2% would be 102%, and then just move your decimal over 2 places to the left, changes the percent to a decimal, would be 1 and 200 N. If we look at number 2, the area of a garden plot can be represented by expression 84z minus 54. The garden will be divided into 6 sections for planting 6 different vegetables. The sections will be equal in area. Write an expression that represents the area of each section. So if we look at this, we have 84z minus 54. So if you want to, they're subtracting, you can add the opposite there if you'd like. And we have this divided into 6 sections that are all equal. What that means is that we would actually, for this to work, if this is divided into 6 equal sections, we should be able to factor a 6 out of this. It's possible a bigger number might work, but for this problem, we have 6 sections. We want to split it up and factor it by 6. So if you do 84 divided by 6, is 14. So in other words, 6 times 14z would have given us 84z. And then if we take 54 divided by 6, we might know that one would be 9. So 6 times negative 9 would be negative 54. So 6 times the quantity 14z plus negative 9, that means we have 6 of these sections. So the area of one section would be 14z plus negative 9, or 14z minus 9. So reminder, we've got assignments posted on the pearsonrealize.com website that you guys can do to get some more practice on these. It'll tell you if you're getting the answers right or not as you work through that. And make sure you're studying here, and then tests will be tomorrow. Lessons 4.5 through 4.8.